There is a storm forming on the Gulf right now that the models say may break one of the oldest rules in tropical meteorology, the rule that a storm has to die once it leaves the ocean. Instead, this one is forecast to move inland and get stronger, crawling across the deep south while it drops as much as a foot of rain, and it is only half of the story. 900 miles to the north, the same enormous pattern is loading the Midwest for a violent tornado outbreak, and by Thursday more than 120 million Americans will be under some kind of severe threat. The two are not separate events, they are one machine. And the question I cannot stop thinking about is this: if a storm can gain strength over dry land, what does that tell us about the summer ahead? If you find that as fascinating as I do, hit subscribe and like, and tell me in the comments which side of this you are watching from. Let's dive in. Part 1. The map nobody wanted to see in June. There is a version of this map that forecasters dread, and this morning they drew it. A wide block of red was painted across the middle of the country, centered on central Illinois and reaching into northwest Indiana, and that red is not a color any meteorologist uses casually. It is a level 4 out of 5. It is a moderate risk of severe weather, and the word moderate is one of the great misnomers in all of science, because there is nothing moderate about what it means. It is the second highest category that exists. It is the category reserved for the days that end up with names, the days people in Peoria and Springfield and Champaign will talk about for years. And the thing that should stop you cold is not just that the map exists. It is the date on the corner of that map. It is the middle of June. You're not supposed to see this in the middle of June. By the back half of June, the great engine that drives these outbreaks has usually pulled north into Canada. The jet stream has lifted away, and the weather across the heartland settles into something lazy and humid. The kind of afternoon where a thunderstorm pops up, dumps rain on one county and falls apart by dinner. That is the June we expect. That is the June the calendar promises. And that is not the June that is about to happen. Instead, the atmosphere has reached back into the wrong season and pulled out a setup that belongs to April, a setup so far outside the normal range for this time of year that the forecasters describe it with a phrase they almost never use. They say it only happens once every few years, so that is where we begin today with a single question that is going to run underneath everything we talk about in this video. Why is the sky over America about to behave like the worst of spring, weeks after spring is supposed to be over? Because the answer is not one storm. The answer is one enormous anomalous machine in the upper atmosphere, a machine that is about to do two completely different things at the same time in two completely different parts of the country. And the fact that both of those things trace back to the same source is the part almost no one is talking about yet. On one side, it is going to try to spin up a violent tornado outbreak across the Midwest tomorrow. On the other side, down along the Gulf, it is helping to give birth to a storm that may break one of the oldest rules in tropical meteorology. Hold on to that, because we are going to follow the thread all the way from a cornfield in Illinois to a flooded street in Mississippi to a coastline in the Carolinas, and you are going to see how a single pattern ties all of it together. Let me show you what the people whose job it is to watch this are actually saying, because their language tells you everything. The Storm Prediction Center, the office in Norman, Oklahoma that issues these outlooks, did not hedge. They wrote that an outbreak of severe thunderstorms is expected, and then they listed what is on the table: intense tornadoes, swaths of damaging gusts to 80 miles per hour, hail to 2.5 inches in diameter. Read those words again slowly, because each one is doing heavy lifting. They did not say tornadoes are possible. They said intense tornadoes. They did not say it might get windy. They said swaths, plural, of damaging winds, and the local weather office in Chicago went further, writing in plain language that a dangerous severe weather outbreak, including the potential for long-tracked, strong to violent tornadoes, is possible, especially south of Interstate 80, long-tracked. That single word should make the hair on your arm stand up, because a long-track tornado is not the brief spin-up that touches down, knocks over a few trees, and lifts. A long-track tornado is the kind that stays on the ground for tens of miles, the kind that does not give a town the mercy of a near miss, the kind that carves a scar you can see from a satellite. And the forecasters are using that word 2 days before it happens, which tells you something about how confident they are in the ingredients. We will get to those ingredients because they are genuinely incredible, and I want to walk you through them one by one so you understand not just what is being forecast, but why. But first, I want you to sit with the strangeness of the timing, because the timing is the whole story. When you have done this long enough, you start to read the calendar like a clock. March, April, and May are the loud months. That is when the cold air left over from winter is still wrestling with the warm, wet air pushing up from the Gulf of Mexico, and that wrestling match is what makes tornadoes. By the time you get to late June, one side has usually won. The cold air has retreated, the fight is over. The atmosphere stops generating those violent collisions because it no longer has the raw materials. So when a setup like this shows up on the 17th of June, it is not just an aggressive forecast. It is the atmosphere doing something it is statistically not supposed to be able to do this late, and that is the part that has the forecasting community leaning in. There was a video we made earlier this month back on the 10th of June where we looked at the long-range pattern and said, the final 2 weeks of June were going to turn unusually active, that something was building that most of the country was not ready for. A lot of people in the comments were sceptical. June is quiet, they said. June is the slow season. And here we are. This is that forecast arriving on the doorstep, and it arrived meaner than even that long-range guidance suggested. So if you have been following along, this is not coming out of nowhere for you. You watched the fuse get lit, now we are watching it burn down. And there is one more piece of context that makes tomorrow even more sobering. Only about a week ago, this same region, the Midwest, took a hit from a severe weather event that produced multiple large tornadoes. The ground is still raw. People there have barely finished cleaning up, and the forecasters are now saying, in writing, that tomorrow's setup is more favourable for tornadoes than the one that already did the damage a week ago. Think about what that means. The bar was already high. The atmosphere is about to clear it with room to spare. When a meteorologist tells you the environment is more favourable than the one that just spawned multiple tornadoes in the same place, they are not trying to scare you. They are trying to get you to take a plan seriously before the sirens go off, because by the time the siren sounds, the time to make a plan is already gone. To be clear, June is not incapable of producing severe weather. Thunderstorms are a near daily feature of a Midwestern summer, and even the occasional June tornado is not unheard of. But there is a difference between the ordinary summer storm, the kind that fires in the afternoon heat, dumps rain on a county, and collapses by evening, and an organised, dynamically driven outbreak powered by a sharp trough and a screaming jet. The first is the background noise of summer. The second is a creature of spring. And what makes tomorrow so notable is that the calendar says summer while the atmosphere has built something that belongs unmistakably to the violent middle of spring. That mismatch is precisely what makes it dangerous, because danger and complacency are a deadly pairing. In April, people across the Midwest are primed. They watch the sky. They know it is tornado season. By the middle of June, that vigilance has relaxed. The mental guard is down. Graduations, ball games, vacations, long evenings in the backyard, that is what June is for, not tornado drills. So when a spring-caliber outbreak drops into the middle of June, it arrives at the exact moment when the public is least expecting it and least prepared for it. And that gap between the threat and the readiness is the space where tragedies happen. It is the entire reason a video like this one matters days ahead of time. So here is the shape of what is coming, and I want to lay it out cleanly before we go deep into the why. Today, Tuesday, is the warm-up, a scattered set of lower-end threats that are mostly the atmosphere clearing its throat. Tomorrow, Wednesday, is the main event, the moderate risk, the tornado outbreak, the day everything is pointing at. Thursday, the threat does not end, it spreads, eventually putting more than 120 million people under some level of severe weather risk from the Gulf Coast all the way to New York City. And then, threaded underneath all of it, there is that second story brewing down on the Gulf, a tropical system that the National Hurricane Center is watching closely, a system that could become the first named storm of the Atlantic season, and that may do something genuinely strange once it moves inland. All of it, the tornadoes and the tropical storm and the historic rain, is being conducted by the same hand. And by the end of this video, you're going to see exactly how. For now, hold this picture in your mind, a red box on a map in the middle of June, over a part of the country that just got hit a week ago, drawn by forecasters who chose the word intense and the word violent on purpose. That is not normal. That is the opposite of normal. And the reason it is happening is sitting about 35,000 feet over your head in a river of wind that should not be where it is right now. So let me take you up there, into the engine room of this entire event, because once you understand what is happening at the top of the atmosphere, everything that happens at the surface tomorrow is going to make a terrible kind of sense. Part 2. A winter engine in the wrong season. To understand why tomorrow is going to be so dangerous, you have to stop looking at the ground and look up, way up, to a layer of the atmosphere that most people never think about. About 18,000 feet above your head, roughly halfway up through the weight of the atmosphere, there is a pressure level that meteorologists call 500 millibars. It is the level they use to read the true personality of a weather pattern, because that is where you find the steering currents, the rivers of fast-moving air that push storm systems around like leaves on a stream. And this morning, the map at 500 millibars over the United States looks like something pulled from the middle of March, not the middle of June. Here is the number that matters, and I want you to really feel it, because it is the single most important statistic in this entire forecast. The heights at that 500 millibar level over the storm are running 3 to 4 standard deviations below normal for the middle of June. Now, if the phrase standard deviation makes your eyes glaze over, let me translate it into something you can hold. In statistics, almost everything that ever happens falls within 2 standard deviations of average. That covers something like 95% of all cases. When you get out to 3 standard deviations, you're talking about events that happen less than 1% of the time. 4 standard deviations is rarer still, the kind of outlier that shows up a handful of times in your entire life. So when the atmosphere is running 3 to 4 standard deviations away from where it should be for mid-June, the sky's not just having an unusual day, it is doing something that, by the numbers, it is almost not allowed to do this time of year. What that anomaly actually represents in plain terms is a trough, a massive southward plunge of the jet stream, digging out of Canada and across the northern United States. Picture the jet stream as a ribbon of wind circling the planet. Most of the time in summer, that ribbon is pulled taut and lifted up toward the pole, well to the north of the lower 48. But every so often the ribbon buckles, and a huge piece of it dives south, dragging cold, fast air down from Canada into the middle of the country. That buckle is the trough. It is a winter and springtime feature, and right now there is one carved so far south and so sharply that the air at the top of the atmosphere is colder and faster than it has any business being in the back half of June. And here is where it gets serious. As that trough swings east, it is going to spin up a low pressure system at the surface, and the forecasters are watching that surface low with something close to disbelief, because the guidance suggests it could approach an all-time record low barometric pressure for the entire month of June over the upper Midwest. Let me make sure that lands, not a record for the week, not a record for the day. A possible record low pressure for the month of June, period, in records that go back over a century. The strength of a storm system is written in how low its pressure drops, the way the strength of an engine is written in how hard it can pull. The lower the number, the more violently the atmosphere has to rush in to fill the void, and the more energy the whole system can wring out of the air around it. A June storm flirting with an all-time pressure record is a June storm behaving like a powerful cold season cyclone, and that is exactly the kind of engine that manufactures tornado outbreaks. Now watch how the engine connects to the weapon, because this is the part that turns a number on a chart into a threat on the ground. That fast air at 500 millibars is going to translate into a jet stream core, what we call a jet streak, of 60 to 80 knots of wind screaming across the Midwest tomorrow. 60 to 80 knots is roughly 70 to 90 miles per hour of wind, more than 3 miles above the surface, and it is going to strengthen even further after dark. Underneath it, lower down at about 5,000 feet, a second river of wind called the low-level jet is going to crank up to 50 to 60 knots, aimed out of the south, pumping warm, wet air from Kansas up into Iowa, and then fanning it northeast across Illinois, Indiana, and Ohio through the evening. Why does that matter? Because tornadoes are not made by wind speed alone. They are made by wind shear, by the change in wind speed and direction as you climb up through the atmosphere. When you have a strong wind out of the south near the ground, and an even stronger wind out of the west far above it, the air in between gets rolled, like a pencil rolling between your palms, into horizontal tubes of spinning air. And when a thunderstorm's updraft, its column of rising air sucks one of those spinning tubes upward and tilts it vertical, You have the seed of a rotating storm. You have a supercell. And a supercell is the species of thunderstorm that produces almost every violent tornado that has ever been recorded. Tomorrow, the atmosphere is going to be laced with exactly that kind of shear, from the surface all the way up to the jet, across a warm sector the size of several states. This is the moment to remember what we talked about back in our video on this year's strange tornado season, where we got into the science of how a warming Gulf of Mexico and the swing between El Niño and La Niña can reorganize where and when these outbreaks happen. There is real research behind this, work showing that the environments that breed severe storms, the combination of instability and shear, have been shifting and in some measures intensifying. We are not going to relitigate all of that today, but I bring it up because tomorrow is, in a sense, a case study in that exact idea. The Gulf of Mexico right now is running warm, unusually warm, and a warm Gulf is a fuel tank. It loads the lower atmosphere with moisture and heat, and when a winter-strength trough reaches down and lights that fuel, you do not get a normal June afternoon. You get the map we opened this video with. It helps to picture the jet stream the way you would picture a rope tied at both ends and shaken. Most of the time in summer, that rope is pulled fairly straight and lifted up toward the pole, and the weather underneath it is calm and predictable. But every so often the rope is shaken hard enough that it buckles into enormous waves, great ridges that bulge north and great troughs that plunge south, and those waves can lock into place and stand nearly still for days at a time. Meteorologists call them Rossby waves, the planetary scale meanders of the jet, and they are the master switches of our weather. When a ridge parks over you, you bake under clear skies. When a trough parks over you, the door swings open for storm after storm. What makes this week so unusual is the amplitude of that wave, how far south the trough is reaching, and how late in the year it is doing it. By the middle of June, these meanders are supposed to flatten out as the whole system relaxes into summer. Instead, the rope has been shaken into a sharp trough and then locked in place, and the atmosphere is pouring all of its cold, fast, springtime energy through that one buckled section of the country. The depth of the trough is what gives us the record flirting low. The fact that it is stuck is what gives us a week of storms instead of a single bad afternoon. And the timing, this far into June, is what turns the whole thing into a genuine statistical outlier rather than just another spring system. So let me put the engine back together for you, piece by piece, because every part is now in place. You have a trough 3 to 4 standard deviations beyond normal, a statistical freak for mid-June. You have a surface low that may set an all-time June pressure record. You have a jet streak of 60 to 80 knots aloft, and a low-level jet of 50 to 60 knots below, crossing each other to manufacture shear, and you have a warm, wet Gulf air mass surging north to provide the fuel and the instability. Each of those alone would get a forecaster's attention. All of them stacked together, in the same place, on the same afternoon in the middle of June, is why the word outbreak is being used 2 days in advance. But I've only shown you half of the recipe. Shear is what makes a storm spin. It is not what makes a storm explode upward with enough violence to put a tornado on the ground and keep it there. For that, you need the other ingredient, the one that comes up from below rather than down from above, and tomorrow that ingredient is going to be loaded into the atmosphere over the Midwest in quantities that, like everything else about this setup, do not belong in June. So let me show you what is waiting at the surface, and the single number forecasters are using to measure just how primed this sky really is, because when you see how high that number climbs, you will understand why nobody who does this for a living is treating tomorrow as just another summer storm day. Part 3. The recipe for a violent afternoon. Imagine the atmosphere tomorrow afternoon as a pot of water sitting on a stove, except the stove is the warm, wet ground of the Midwest in mid-June, and the lid is a layer of warm air aloft holding everything down. What we have been describing so far, the trough, the jet streaks, the shear, all of that is the spin you can put on the pot. But spin alone does nothing if the water never boils. What makes a thunderstorm erupt with violence is the boil itself, the explosive upward rush of warm air, and the fuel for that boil has a name. Meteorologists call it CAPE, which stands for convective available potential energy, and it is, quite literally, a measurement of how much explosive energy is stored in the atmosphere waiting to be released. Tomorrow, across the warm sector, that CAPE is forecast to climb to somewhere between 2,500 and 3,500 joules per kilogram. I know that unit means nothing to most people, so let me give you the translation that matters. Those are strong values for any time of year. In the middle of June, with a setup this dynamic on top of them, they are a loaded gun. The reason that energy is going to be there is the warm front, a boundary that is going to lift north through Illinois, Indiana, and Ohio, dragging dew points up into the upper 60s and near 70 degrees. A dew point near 70 is a tropical-feeling, sticky, oppressive air mass, and that humidity is not just discomfort, it is fuel. Every gram of water vapour in that air carries hidden heat, and when it gets lifted and condenses inside a storm, that heat releases and drives the updraft harder, the way throwing gasoline on a fire makes the flames leap. So now put the two halves together, the spin from above and the boil from below, and you get the most dangerous machine in the atmosphere, the supercell. Here is how it actually happens, step by step, because I think when you understand the mechanism, the forecast stops being abstract. The sun heats the ground, the warm, humid air rises, and it punches up through that warm lid until it breaks free and explodes upward into a towering thunderstorm. As that updraft rockets skyward, it runs into all the shear we talked about, the wind changing speed and direction with height. The shear tilts the rising column and sets it spinning, and now you do not just have a thunderstorm, you have a rotating thunderstorm, a storm with a spinning core that meteorologists call a mesocyclone. That rotation is the parent of the tornado. Not every supercell drops a tornado, but almost every violent tornado comes from a supercell, and tomorrow the atmosphere is going to be building them across a huge area. It is worth pausing on what those tornado ratings actually mean, because the numbers can feel abstract until you translate them into what they do. The scale we use runs from EF0 at the weak end to EF5 at the catastrophic end, and it is based on the damage the winds leave behind. An EF3 tornado, the kind explicitly on the table tomorrow, carries winds of roughly 140 to 165 miles per hour, strong enough to level well-built homes, snap large trees and throw vehicles. An EF4 climbs past 165 miles per hour and can sweep a sturdy house clean off its foundation. These are not the brief, rope-like spin-ups that do a little cosmetic damage and lift. These are the machines that erase neighbourhoods, and the environment tomorrow is capable of building them. When forecasters use the word violent, that is the specific technical thing they mean, and it is why the tone of this forecast is what it is. And the speed at which these storms will move tomorrow makes them even more dangerous. With that powerful jet overhead, the supercells are expected to race along at highway speeds, which means the window between a warning and the arrival of the tornado could be brutally short, a matter of minutes rather than the comfortable lead time people imagine. A fast-moving tornado gives you less time to react, less time to get your family to shelter, less time to make the right call. That is one more reason the only safe move tomorrow is to have your plan settled before the watches even go up. Now here is the number that should make you put down whatever you're doing and pay attention. Forecasters use a single index to fold all of these ingredients together: the shear, the instability, the lifting, the low-level spin, into one value that tells you how favourable the environment is for strong tornadoes specifically. They call it the significant tornado parameter. On an ordinary severe weather day, you might see values around 1. Tomorrow, across that warm sector, the significant tornado parameter is forecast to reach values of 5 to 9, and locally even higher than that. Let me tell you what that means, because there is a threshold buried in it. Any time that parameter climbs above 7, you are in the territory of violent tornadoes, the EF4 and stronger range, the most destructive winds the planet produces at ground level. And we are not talking about that number spiking in one tiny spot. We are talking about it being elevated across a warm sector that spans multiple states. That is why the Storm Prediction Center put a 15% hatched tornado risk on the map. And I want to explain exactly what that little piece of jargon means, because it is easy to hear 15% and think the odds are low. That 15% is the chance of a tornado within 25 miles of any given point, which over a whole region adds up to a near certainty that tornadoes will occur somewhere in that zone. And the hatching, those cross-hatched lines drawn inside the area, is the part that matters most. The hatching means the forecasters expect a real chance of significant tornadoes, EF2 or stronger, and they have said in plain words that intense tornadoes, the EF3 and beyond, are on the table. Some of the high-resolution computer models are even hinting at probabilities that would justify bumping that 15% up to 30% on a later update, and a 30% hatch tornado risk is the kind of number you see only a few times a year, on the worst days. There is a corridor inside all of this that deserves a special mention, a zone stretching from around Columbia and Jefferson City, Missouri, eastward across Illinois and Indiana toward Toledo, Ohio, where the threat for those significant EF2 and stronger tornadoes is highest. If you live anywhere along that line from mid-Missouri through central Illinois and Indiana into northwest Ohio, tomorrow is not a day to keep half an eye on the sky. It is a day to have a plan, to know where your safe room is, to have more than one way to receive a warning, and to keep your phone charged. I am not telling you that to frighten you. I am telling you that because the entire point of a forecast like this, issued a full day ahead, is to buy you time, and time is the only thing that saves lives when a violent tornado is on the ground. There is one more ingredient I have to mention, because it is the trigger that decides whether all this stored energy actually gets released, and it is called the cap. The cap is a thin layer of warm air a few thousand feet up that acts like a lid on a pot, holding the warm, buoyant air at the surface in place even as it strains to rise. A strong cap can suppress storms entirely, keeping a loaded atmosphere quiet right up until something breaks the seal. A weak cap lets storms erupt too early and too messily, often as a disorganized line. The dangerous sweet spot is a cap that holds just long enough to let the surface air grow explosively unstable, and then breaks in a few isolated spots, letting a handful of storms tap all that pent-up energy at once. How the cap behaves tomorrow afternoon is one more reason the exact outcome is so hard to call. On top of that sits the question of where the warm front ends up, and that single boundary may decide where the worst tornadoes track. The warm front is the line between the cooler air to the north and the warm, humid, unstable air surging up from the south, and the air just on the warm side of that boundary, where the low-level winds bend and turn, is some of the most tornado-favourable ground the atmosphere can produce. If that front lifts a little farther north than expected, it drags the highest threat into different towns than the forecast suggests. If it stalls farther south, the bullseye shifts the other way. A wobble of 50 or 100 miles in the position of one invisible boundary can be the difference between which communities spend tomorrow evening in their basements and which ones watch the storms pass to their north. That is the razor edge these forecasts are balanced on. And remember, every bit of this is still tied to the engine we described in the last part. The same trough that is too deep for June, the same record-flirting low pressure, the same crossing jets, are what is generating the shear and lifting the warm sector and sharpening that warm front. This is not a collection of separate problems, it is one system, one anomalous June machine, expressing itself as instability at the surface and rotation in the storms. Hold that thought, because in a few minutes we're going to watch the exact same machine reach down to the Gulf Coast and try to build something completely different, and the through line is going to matter. But before we travel south, there is a question we have not answered yet, and it is the question that will decide whether tomorrow becomes a historic day or merely a dangerous one. We have the ingredients. We have the energy and the spin and the fuel. What we do not yet know is how the storms will choose to organize themselves once they fire, because the atmosphere has two very different ways of releasing all this violence, and the difference between them is the difference between scattered long-lived tornado machines and a single roaring line of wind. So let me take you into the hours of tomorrow afternoon and evening, hour by hour, and show you the one variable that even the best forecasters in the world cannot yet pin down. Part 4. The hours that decide everything. The clock is going to matter tomorrow more than almost anything else, so let me walk you through the day the way a forecaster watches it unfold, hour by hour, because the timeline itself tells a story. The morning is not the main concern. There will likely be a cluster of storms rolling along in the early hours, somewhere from round Davenport back toward Springfield, throwing down some damaging straight-line winds and large hail, and that morning activity actually matters for a subtle reason we will come back to. But the real show begins when the sun gets to work. As the afternoon heating builds and that warm sector opens up, the atmosphere is going to reach the point where it can no longer hold itself down, and the storms will begin to fire. Around 4 o'clock in the afternoon local time is when forecasters expect the first storms to initiate. By 5 o'clock, they expect to see the real thing, legitimate discrete supercells going up across the Midwest. And here is a detail that genuinely stopped me when I saw it. One of the high-resolution models, the kind that tries to simulate individual storms rather than the broad pattern, printed out something on its latest run that you almost never see modelled. At 5 o'clock in the afternoon it showed 5, even 6 separate discrete supercells dotting the Midwest at the same time. Let me tell you why that is so unsettling. A discrete supercell is a storm that stands alone, with clear air around it, no other storm stealing its fuel, free to ingest all that energy and shear and wind itself up into a violently rotating machine. 5 or 6 of them, going at once, across a warm sector this primed, is the recipe for multiple simultaneous long-lived tornadoes. It is not a guarantee, but the fact that a model is even painting that picture is a warning in itself. Now we arrive at the single biggest uncertainty in the entire forecast, the one variable that even the sharpest forecasters in the country admit they cannot fully resolve until it's happening, and it comes down to a question of storm mode. There are 2 ways tomorrow can go. In the first scenario, those storms stay discrete, separate from one another, each one a standalone supercell free to produce strong, long-track tornadoes for hours. That is the nightmare scenario, the one that maximizes the violent tornado threat. In the second scenario, the storms fire so explosively and so close together that they quickly merge into one long, continuous line, what we call a squall line. And while a squall line is extremely dangerous in its own right, throwing down widespread damaging winds and the occasional spin-up tornado, it does not usually produce the same parade of strong long-track tornadoes that discrete supercells do. Which one happens tomorrow is the whole ball game, and the honest answer is that nobody knows yet. There was a severe weather event in this same region only about a week ago where exactly this question played out. Forecasters watched supercells try to go up in eastern Illinois, and then a line of storms in western Illinois upscaled so fast that it changed the character of the whole event. That kind of thing is genuinely difficult to predict more than a few hours out. It can come down to where that morning cluster of storms I mentioned earlier ends up, because morning storms can disturb the atmosphere, work over the air, and change how the afternoon recovers. So when you hear a forecaster tomorrow say they are watching storm mode, this is what they mean. They are watching to see whether the sky chooses scattered individual monsters or one long roaring wall, and the answer will determine whether tomorrow is remembered as a damaging wind event or as a major tornado outbreak. Pay special attention to that morning round of storms, because it is the joker in the deck. Those early storms rolling from around Davenport towards Springfield are not the main threat themselves, but what they do to the atmosphere could shape the entire afternoon. If they linger and spread a shield of clouds across the warm sector, they could rob it of the afternoon sunshine it needs to fully destabilize, and a shaded, worked-over atmosphere might never reach its violent potential. But if those morning storms clear out quickly and the sun breaks through by midday, the warm sector recharges, the instability builds back to its full and dangerous level, and the stage is set for the worst-case afternoon. Forecasters will be watching satellite imagery all morning for exactly this, trying to read how fast the air recovers, because the speed of that recovery is one more thread the whole outcome hangs on. Let me give you the rest of the timeline, because the threat does not switch off at sunset. The peak window for tornadoes tomorrow is expected to run roughly from 4 o'clock in the afternoon to 9 o'clock at night, but the broader threat stretches from around 2 in the afternoon all the way to 2 in the morning and possibly later. There are actually 2 areas to watch. One is up near the surface low itself, into Wisconsin and Minnesota, where storms developing between 3 and 6 o'clock could produce a couple of tornadoes, though the stronger tornado threat there looks lower. The area that has forecasters far more concerned is down in the Midwest, where all the upper-level and low-level winds overlap most perfectly the zone we have been circling this entire video, from Illinois into Indiana, and then comes the part that frightens me the most, because it involves the clock running into the dark. As the evening goes on, somewhere around 9 or 10 o'clock, those storms are expected to begin congealing into a line, more broken in some places than others, stretching from around St. Louis and Springfield up toward Detroit. That line is going to keep producing damaging winds and embedded tornadoes, and it is going to do it after dark, possibly holding together until it reaches around Lexington, well after 1 in the morning. Nighttime tornadoes are, statistically, far more deadly than daytime tornadoes, for the simple and human reason that people are asleep. They do not see the sky. They do not get the warning. They do not wake up. That is why, if you live anywhere in this corridor, the single most important thing you can do tonight is make sure you have a way to be woken up by a warning, a weather radio, a phone alert that will break through, anything that will pull you out of sleep if the line bears down on your town in the middle of the night. I want to dwell on that nighttime line for a moment, because the after-dark hours are where tornado events turn truly deadly, and the reason is painfully human. Study after study has found that tornadoes which strike at night are far more likely to kill than the ones that strike in daylight, and it is not because the tornadoes themselves are stronger, it is because we are asleep. We do not see the sky turn, we do not hear the neighbours, we do not get the visual confirmation that finally makes a person take shelter. The warning has to be loud enough and insistent enough to pull us out of sleep, and far too often it is not, or the phone is on silent, or the power has already gone out and taken the television with it. That is why a line of storms pushing through Illinois and Indiana toward Kentucky after midnight tomorrow is so much more frightening than the same storms would be at noon. The danger multiplies for anyone living in a mobile or manufactured home, which offer almost no protection against even a weak tornado, let alone the strong ones possible tomorrow. If that describes where you live, the single most important decision you can make is to identify, today, a sturdier building you can get to quickly, a neighbour basement, a community shelter, a permanent structure with an interior room, and to go there early, before the warning, not after. The people who survive violent tornadoes are almost always the ones who decided what to do before the sky gave them a reason to panic. The ones who wait to see it coming are the ones who run out of time. None of this is meant to terrify you. It is meant to make the plan automatic so that when the alert sounds in the dark, your body already knows where to go. So that is tomorrow, laid out hour by hour from the first storms at 4 o'clock to a nocturnal line of wind and embedded tornadoes pushing toward Kentucky past 1 in the morning. And underneath all of it sits that one unanswerable question of storm mode, the difference between scattered monsters and a single wall, a question the atmosphere will not answer until we are inside the event itself. But I have been talking about this threat in terms of jet streaks and parameters and storm modes, and I do not want to lose the most important part, which is that all of these lines on a map cross over real places, real towns, real people who are going to spend tomorrow watching the sky. So let me bring this back to the ground, to the specific cities sitting under the pen, and to the human reality of what a day like this actually asks of the people in its path. Part 5. The Cities Under the Pen. Let me read you the names, because a forecast stops being abstract the moment you hear the name of a place where people live. Inside that red moderate risk box, the highest threat zone, sit Peoria, Springfield and Champaign in Illinois, and Lafayette over in Indiana. Wrapped around that core is a larger area, the Level 3 enhanced risk, and it pulls in some of the biggest population centers in the middle of the country. It reaches from the Chicago metro down towards St. Louis, and it covers Columbia, Indianapolis, Fort Wayne, and stretches into the far northwest corner of Ohio. And then around that, a slight and marginal risk fans out even wider, touching Minneapolis, Lexington, Pittsburgh, Cleveland, Detroit, Wichita, and Columbus. When you add it all up, the forecasters made a point that I want to repeat exactly, because it cuts through everything. They said it almost does not matter where you are in this region tomorrow. The risk of significant severe weather is nearly everywhere. Tornadoes are the headline, but they are not the only weapon in play tomorrow, and the other two are serious enough that they would make news on any normal day. Start with the wind. The Storm Prediction Center has drawn a 30% hatched wind threat across a large area from western Missouri into western Ohio. And that hatching, just like with the tornadoes, is the tell. It means they expect the potential for gusts of 75 miles per hour or greater. 75 miles per hour is hurricane force. Let that sink in. Even in the places that never see a tornado tomorrow, the straight-line winds alone could reach the strength of a Category 1 hurricane, the kind of wind that snaps power poles, peels roofs, and turns loose objects into projectiles. Forecasters specifically called out the potential for gusts up to 80 miles per hour and noted that an even higher wind probability had been on an earlier outlook and could well be added back in. Then there is the hail, and tomorrow's hail threat is the stuff of nightmares for anyone who owns a car or a roof. There is a 30% hatched hail threat, and the hatching here means stones larger than 2 inches in diameter. But the forecasters went further and pointed at western Illinois, just outside Chicago, as a zone where the largest stones could reach the size of baseballs. A baseball-sized hailstone is nearly 3 inches across, and it falls out of the sky at well over 100 miles per hour. It will shatter a windshield. It will punch through a skylight. It can kill livestock caught in the open and seriously injure a person. So when I tell you to protect your vehicle tomorrow, to get it under cover if you possibly can, I am not offering a helpful household tip. I am telling you that the sky over parts of Illinois tomorrow may rain down ice the size of fists. I want to take a breath here and talk about what this actually means for a human being, because it is easy to get lost in the percentages and forget that this is a video about your afternoon, your family, your town. If you live anywhere in that broad zone, here is what tomorrow asks of you. It asks you to know, before lunchtime, where your safe place is, the lowest, most interior room you can get to, away from windows. It asks you to have more than one way to get a warning, because the power might go out and a single source can fail. It asks you to keep your phone charged and your shoes by the door. And it asks you, if a warning is issued for your area, to act on the first one and not wait to see the sky, because with storms moving as fast as these will be moving, the gap between the warning and the wind can be only minutes. None of that is panic. All of it is just preparation, and preparation is the entire reason a forecast exists a day in advance. And here is something worth holding on to. The danger tomorrow is not random. It is the direct, traceable output of that single anomalous machine we have been building this whole video. The trough too deep for June, the record flirting low, the crossing jets, the warm Gulf fuel. Every one of those city names I just read is sitting under the same pattern, the same engine, expressing itself in tornadoes and wind and hail all at once. That is the signature of a truly dynamic setup. A weak summer pattern gives you one hazard in one place. A pattern like tomorrow's gives you every hazard, across half the country at the same time. It is worth understanding just how rarely the Storm Prediction Center reaches for that moderate risk category, because the rarity is itself the warning. On the large majority of days, even active ones, the highest risk issued is a slight or an enhanced. The moderate risk, that level 4 out of 5, gets used only a handful of times in a typical year, and it is reserved for the days the forecasters believe have the potential to become genuinely significant. The days that produce the outbreaks people remember by name and date for the rest of their lives. The very top category, the high risk, is rarer still, sometimes not issued for a year or more at a stretch. So when you see that red moderate risk box, understand that you are not looking at a routine bad weather day. You're looking at a day the most experienced severe weather forecasters in the country have flagged, more than a full day out, as one with the ingredients to turn historic. If you are in that zone, here is exactly what sheltering means when the warning comes, because the specifics matter. Get to the lowest floor of a sturdy building, a basement if you have one. If you do not, go to the most interior room you can find, a bathroom, a closet, or hallway, putting as many walls as possible between you and the outside. Stay away from windows, get under something sturdy or cover yourself with a mattress, cushions, or a heavy blanket, and protect your head, because most tornado injuries come from flying and falling debris, not from the wind itself. If you have bicycle or sports helmets in the house, put them on, especially on the children. Wear shoes in case you have to walk through debris afterward. These sound like small things. They are the difference between a survivable night and a tragic one, and the time to learn them is now, not when the sirens are already going. Now, before tomorrow arrives, today is not entirely quiet, and today is worth a quick look, because it is the opening act of the same play. There is a lower-end set of severe risks scattered around the country right now, a kind of trifecta, with one threat area near Chicago, Indianapolis, and lower Michigan, another down along the Gulf Coast, and a third up in the northern plains. The one near Lake Michigan is the most watchable, where storms developing this afternoon and evening could produce a couple of tornadoes, with the window running roughly from 3 to 8 o'clock this evening. It is not the main event. It is the atmosphere clearing its throat, testing the air, showing you in miniature what it is capable of before it does the real thing tomorrow. If you see storms fire near the lakeshore this evening, understand them for what they are. They are the warning shot. So we have now walked the entire length of the primary threat, from the engine at 35,000 feet down to the names of the towns in its path and the ice and wind it will throw at them. But remember what I promised you at the very beginning. This same machine is doing two things at once, and we have only looked at one of them. While the Midwest is bracing for tornadoes tomorrow, something is stirring far to the south, down over the warm water of the Gulf, and almost nobody is watching it yet because all the attention is on the red box in the Midwest. That is a mistake, because the thing taking shape on the Gulf is, in some ways, even stranger than a June tornado outbreak. It is a storm that may be about to break a rule that meteorologists have treated as nearly unbreakable for as long as there has been a science of hurricanes. So, let me take you south. Part 6. The second storm. Nobody's watching yet. While every eye is fixed on that red box over Illinois, a second drama is quietly unfolding 900 miles to the south, and it begins with a humble label. The National Hurricane Center is tracking a broad area of showers and thunderstorms over South Texas and the Northwest Gulf, and they have given it the designation Invest 90L. That word, invest, simply means a system under investigation, an area the forecasters have flagged as worth watching for development. If you looked at it on satellite right now, you would not see a tidy spinning storm. You would see a sprawling, disorganized blob of moisture and thunderstorms, with only the faintest hint of a low-level circulation trying to get its act together. That is exactly what a tropical system looks like in the hours before it decides whether to become something, and it is deciding right now. As of this morning, the Hurricane Center gave Invest 90L a 60% chance of developing into a tropical system over the next couple of days, and forecasters tracking it closely expected that number to climb, with some already pointing towards 70%. If it does organize, it earns the first name on this year's Atlantic list. It becomes Tropical Storm Arthur, and the window for that to happen is short and soon, most likely within the next 24 to 48 hours, as the center of the system drifts out over the warm open water just off the Texas and Mexico coast, where the ocean can feed it. Before we go further, it is worth pausing on what it even means for a storm to earn a name, because the naming is not just bureaucratic housekeeping. A system gets a name, in this case Arthur, the first name on this year list, once it organizes into a tropical storm with a closed circulation and sustained winds of at least 39 miles per hour. The name is a threshold, a line the storm crosses from disorganized blob to recognized entity. But here is the thing people often miss. The name has almost nothing to do with how much damage a system does. Some of the most destructive flood events in American history came from systems that were barely named, or not named at all, weak-looking storms that simply sat over one place and rained for days. So as you hear the question of whether this becomes Arthur, keep it in perspective. That is what makes this system worth your attention, regardless of what the Hurricane Center ultimately calls it. The development odds, 60% climbing towards 70, tell you the forecasters think organization is likely. But the impacts, the flooding, the tornado threat in the northeast quadrant, the possibility of strengthening over land, all of those are in play whether the final label reads tropical storm, tropical depression, or simply a stubborn area of low pressure. The label is for the record books. The rain is for the people underneath it. But here is the first thing that makes this system genuinely unusual, and it connects directly back to everything we've been talking about. Look at where all its energy is going. The moisture is not staying neatly wrapped around the center the way it would in a classic healthy tropical storm. Instead, an enormous plume of tropical moisture is being flung out to the northeast, hurled across Louisiana, Mississippi, Alabama, and beyond, hundreds of miles ahead of the center itself. Why? Because of the same upper-level winds that are driving the severe weather up north. That powerful flow aloft, the edge of the very same pattern carving the trough over the Midwest, is reaching down and ventilating this Gulf system, pulling its exhaust out and away to the northeast like a chimney drawing smoke. The tornado outbreak and the tropical storm are not two separate weather stories that happen to be occurring on the same day. They are two ends of one continent-sized system. The same hand is on both. That connection is not just a neat observation. It has teeth, because that upper-level ventilation is one of the ingredients that can help a tropical system strengthen, and it is setting up the strangest part of this entire forecast. To explain why, I have to tell you about a rule, one of the first rules you learn about tropical systems. The rule is that they live and die by warm ocean water. A hurricane or a tropical storm is, at its core, a heat engine. It draws its power from the warmth of the sea surface, converting ocean heat into wind and rain. Take away the ocean, push the storm over land, and you cut its fuel line. It is supposed to weaken. It is supposed to fall apart. Every textbook says so, and almost every storm obeys. A tropical system that moves inland is a tropical system on its deathbed. That is the rule, and the models are suggesting that this system may break it. I want to be careful and honest here, because this is the part where speculation enters, and on this channel we always tell you where the solid ground ends and the forecasting frontier begins. What several of the computer models are showing, and the European model is the most aggressive about this, is a scenario where this low does not simply die after it comes ashore. Instead, it moves inland across eastern Texas and Louisiana, and then, rather than fading away, it re-energizes, it deepens. The guidance carries it over Mississippi and Louisiana, strengthens it as it crosses Alabama, drags a closed center of low pressure right over the Birmingham area, then over Atlanta, then into South Carolina, and finally back out over the Atlantic off the Carolina coast, where it could intensify all over again over the warm Gulf Stream. In other words, the models are painting a storm that gets stronger while sitting on dry land, hundreds of miles from the ocean that is supposed to be its only food source. If that sounds like it should be impossible, you are thinking about it correctly, because under normal circumstances it nearly is. And yet the atmosphere occasionally finds a loophole, a way to keep a storm alive and even feed it over land, and the conditions for that loophole appear to be falling into place across the deep south this week. The mechanism behind it is genuinely fascinating, one of those pieces of weather science that sounds almost like a magic trick until you understand the physics, and it ties directly back to the soaked ground, the tropical air, and the same upper-level engine driving the tornadoes up north. So in the next part we are going to nerd out in the best possible way on exactly how a storm can strengthen over land, why it might happen here, and what it would mean for the millions of people from the Gulf Coast to the Carolinas who are about to find out whether the rule holds or breaks. Part 7. The storm that refuses to die on land. So let us nerd out for a few minutes, because the question of how a storm can strengthen over land is one of the most counterintuitive ideas in all of weather, and once you see the mechanism, you will never look at an inland tropical system the same way again. Start with what is happening at the top of this system, tens of thousands of feet up. Remember that powerful upper-level flow we keep coming back to, the same flow driving the tornado threat in the Midwest. Over the Gulf system, that flow is doing something specific. It is spreading apart, fanning outward, in what meteorologists call divergence aloft. Picture the air at the top of the storm being raked outward in every direction, evacuated, pushed away faster than it can be replaced. Now think about what that does to everything below it. When you remove air from the top of a column, you lower the pressure underneath, and nature abhors that imbalance. So air from below rushes upward to fill the space. That rising air is the lifeblood of a storm, because rising air cools, condenses, and builds thunderstorms, and every one of those thunderstorms releases heat as its water vapor condenses, and that heat lowers the surface pressure even further, which pulls in more air, which rises, which builds more storms. It is a self-feeding loop. The outflow at the top keeps pulling, the inflow at the bottom keeps rising, and as long as something keeps the air at the top evacuating, and something keeps the rising air moist, the engine keeps running, whether or not there is an ocean underneath it. Tomorrow and into Thursday, that upper-level jet is going to keep raking the top of this system, acting like a hand on the pump. But the top of the storm is only half of the loophole. The other half is on the ground, and it has a name that sounds almost like a joke until you understand it. Scientists call it the brown ocean effect. Here is the idea. A tropical storm normally needs the warm blue ocean for fuel, because the ocean supplies endless warm, moist air. But if a storm moves over land that is hot, and so completely saturated with water that it behaves like a shallow sea, that soggy ground can keep supplying the warm, moist air the storm needs. The land, in effect, pretends to be an ocean. It becomes a brown ocean. And the deep south this week is being set up to become exactly that, because days of tropical downpours are soaking the soil across Louisiana, Mississippi, and Alabama, priming the ground to release heat and moisture back into the storm as it passes over. Warm, waterlogged earth under a humid sky, with the upper atmosphere actively pulling air out of the top, is the recipe that lets a storm cheat death on land. Watch how the models show this playing out, because the fingerprints are all over the guidance. The European model deepens the surface low from around 1006 millibars off the Texas coast, down toward 1003 millibars as it organizes, then carries that strengthening signal inland rather than letting it collapse. Other guidance agrees on the basic idea. Even the newer artificial intelligence weather models, which learn patterns from decades of past storms rather than solving the physics equation by equation, are independently flagging this system strengthening as it moves inland and into the southeast. When the old physics-based models and the new pattern learning models both point at the same strange outcome, that is when a forecaster's eyebrows go up. And if you look at a field called low-level vorticity, which is just a measurement of spin near the ground, the guidance shows that spin actually intensifying as the system crosses Alabama and heads east, exactly the signature you would expect if the brown ocean loophole is real this week. I want to anchor this back to the bigger picture, because it is easy to get lost in the machinery. Everything I just described, the divergence aloft, the rising air, the self-feeding loop, is being made possible by the same continent-spanning pattern that is about to drop tornadoes on Illinois. The upper-level flow that ventilates this Gulf system is the southern flank of the trough digging into the Midwest. The warm, moisture-loaded air that soaks the deep south is the same Gulf fuel feeding instability up north. This is one machine. It is producing a violent tornado outbreak on its northern edge and a rule-breaking, land-strengthening tropical storm on its southern edge, and the fact that those two things are physically connected is the part of this story that the day-to-day coverage is going to miss, because the tornado outbreak will be on one channel and the tropical storm will be on another, and almost no one will tell you they are the same event. Now, I have to be honest with you about the uncertainty, because intellectual honesty is the whole point of what we do here. Not every model is equally aggressive about this. The American model is weaker and faster, hustling the system through without much strengthening. Another model keeps the low more modest. The European model is the boldest, with the dramatic overland intensification and the loop out to the Carolinas. The ensemble guidance, where you run the model 51 times with slightly different starting conditions and see how many agree, shows most members deepening the low near the Texas coast, then all of them eventually moving it back inland, with only a minority of members carrying that strengthening all the way to Georgia and South Carolina. So the overland strengthening scenario is a real, physically grounded possibility, supported by genuine mechanisms, but it is not a certainty. It is the wild card, and the reason it matters so much is that whether or not this storm strengthens overland changes everything about what it does to the millions of people in its path, starting with the single most dangerous thing it is already guaranteed to do, regardless of whether it ever earns a name. It is going to rain, and it is going to rain in amounts that the word heavy does not begin to capture. Part 8. The catastrophic rain. If you take away only one thing from the southern half of this story, let it be this. Whether or not this system ever becomes Tropical Storm Arthur, whether or not it strengthens over land, the rain is coming, and the rain is the part that is most likely to cost lives. Forget the name on the storm for a moment. Names are for headlines, water is for funerals, and the water that is about to fall across the Gulf Coast and the deep south over the next several days is being described by the forecasters in language they reserve for genuine emergencies. Here are the numbers, and they are sobering. The Weather Prediction Center, the office responsible for rainfall and flooding forecasts, has placed a moderate risk of excessive rainfall, a level 3 out of 4 on their scale, across a large stretch of the region. The expected totals are widespread, 4 to 9 inches of rain over a broad area, with some locations easily exceeding that, and in the worst hit zone, around Jackson and southern Mississippi, into Louisiana and Alabama. The guidance points toward totals approaching, and in spots exceeding, a full foot of rain. One regional model showed isolated areas picking up more than 12 inches. Forecasters use the word catastrophic, and that is not a word the National Weather Service throws around lightly. A foot of rain in a few days is the kind of total that turns creeks into rivers, rivers into lakes, and city streets into channels deep enough to float a car. Look at where the bullseye sits, because the geography's brutal. On Thursday, the highest flood threat lines up along the Interstate 20 corridor, a 40% chance of flash flooding within 25 miles of any point, and that corridor runs right through a string of cities: Alexandria, Baton Rouge, Hattiesburg, Jackson, Montgomery, and Birmingham. Earlier in the stretch, the Texas coast takes the first blow, with Houston in line for around half a foot of rain, and the precipitable water values over southeast Texas, which is a measure of how much total moisture is loaded into the column of air overhead, are running between 2.1 and 2.6 inches. Those are among the highest values ever recorded there for the middle of June. The atmosphere over Texas right now is holding nearly as much water as it physically can, and all of it is available to be wrung out. Down near Corpus Christi, one waterway, Oso Creek, is already forecast for major flooding, the most serious category there is. I want to talk for a moment about why flooding specifically deserves your respect, because it is the hazard people consistently underestimate. Flooding is, in most years, the deadliest weather hazard in the United States, deadlier than tornadoes, deadlier than hurricanes' winds, and the reason is heartbreakingly simple. People do not believe water can take them. They see a flooded road. They have driven through puddles their whole lives and they think they can make it. But it takes only about a foot of moving water to float most vehicles, and once a car is floating, the driver is no longer in control of anything. 2 feet of moving water will carry away almost any vehicle on the road, including trucks and SUVs. More people die in their cars during floods than almost anywhere else, and almost every one of those deaths comes from the same decision, the choice to drive into water that looked shallower than it was. So if you are anywhere in the Deep South this week and you come to a flooded road, I am asking you, with everything I have, to turn around. The phrase the Weather Service uses is turn around, do not drown, and it exists because the alternative happens over and over every single year. It helps to understand why this kind of rain is so much more dangerous than an ordinary downpour, and it comes down to the rate. Forecasters tracking this system have measured rainfall rates exceeding 2 to 5 inches per hour in the heavier cells. Think about what that means. The ground, the storm drains, the creeks, all of it can only carry water away so fast, and when the rain falls faster than the land can drain it, the excess has nowhere to go but up, rising in the streets and the underpasses and the low spots in a matter of minutes. That is flash flooding, and it is a different beast from the slow river flooding that creeps up over days. Flash flooding arrives with terrifying speed, often in the dark, often well away from the river you would think to worry about, turning a dry road into a deadly current faster than a person can react. And the Deep South this week is uniquely primed for it, because the ground is already saturated from days of tropical rain. Saturated ground is like a sponge that is already full. It cannot absorb any more, so nearly all of the new rain becomes runoff, rushing immediately into the waterways and the streets. Layer a foot of new rain, falling at several inches an hour, on top of soil that can no longer soak anything up, and you have the recipe for the catastrophic flooding the Weather Prediction Center is warning about. This is why the flood threat, not the wind, may end up being the deadliest part of the entire southern story, and why the simplest piece of advice is also the most important. When you come to water over a road this week, no matter how shallow it looks, no matter how well you know that road, turn around. And here again is the thread back to the whole. This catastrophic rain is not a separate disaster from the tornadoes up north. It is the same disaster wearing a different mask. The tropical moisture being slung across the Deep South is fuel pulled from the same warm Gulf that is feeding the instability over the Midwest. The upper-level pattern wringing that moisture out over Mississippi is the southern reach of the same trough sharpening the tornado threat over Illinois. When you zoom out far enough to see the whole continent at once, you stop seeing a tornado story and a flood story. You see one enormous, anomalous dune pattern, pressing down on the country from the plains to the Carolinas, and choosing to express its violence as wind in one place and water in another. There is one more dimension to the Gulf system we have not touched yet, and it is the dimension that links it most directly back to the tornado threat that opened this video. Because a strengthening tropical system does not only bring rain and wind, in its northeastern quadrant, the same place all that moisture is being flung, it carries a spin that can drop tornadoes of its own, far from the Midwest, in a part of the country that will spend Wednesday and Thursday watching 2 completely different kinds of severe weather close in from 2 different directions. So let me show you how the tropical system opens a second tornado front across the Deep South, and why, by Thursday, more than 120 million Americans are going to find themselves under some flavour of severe weather threat at the same time. Part 9. The Second Tornado Front. Here is something most people do not realise about tropical storms. They are tornado factories in their own right, and they make their tornadoes in a very particular place. If you draw a tropical system as a spinning wheel, the front right quadrant, the northeastern side relative to its motion, is where the wind shear is strongest, and where small, fast, often rain-wrapped tornadoes tend to spin up. And the northeastern quadrant of this Gulf system is precisely where all that moisture is being flung, across Louisiana, Mississippi, Alabama, and Georgia. So even as the Midwest deals with its violent supercells tomorrow, the Deep South is going to open a second completely separate tornado front, driven not by the trough up north, but by the tropical system itself. The timeline for that southern tornado threat runs a day behind the Midwest. Wednesday night, as the system comes ashore, an elevated tornado threat sets up over Louisiana. Then on Thursday, as the center lifts northeast and the brown ocean engine we talked about keeps it alive, that tornado threat marches with it across Alabama and Mississippi and into Georgia, along a line that stretches roughly from Atlanta down toward Pensacola. These will not, for the most part, be the enormous mile-wide wedges that the Midwest supercells can produce. Tropical tornadoes tend to be smaller and shorter-lived, but they are dangerous in a sneakier way, because they are often wrapped in heavy rain, nearly invisible until they are on top of you, and they spin up fast, sometimes with little warning. A person in Alabama on Thursday could be focused entirely on the flooding, watching the water rise, and never see the tornado coming through the downpour. Then there is the wind, and the wind is where the uncertainty we discussed earlier comes home to roost. In most of the scenarios, even the aggressive ones, the strongest winds, the true tropical storm force gusts of around 40 miles per hour, stay close to the centre and mostly just offshore, with gusty but manageable conditions spreading inland across Mississippi, Alabama, and Georgia. That is the likely case. But there is that wildcard scenario, the one where the system genuinely strengthens over land as it crosses into Georgia and South Carolina, and in that scenario the European model paints a corridor of 50 to 60 mile per hour wind gusts reaching well inland into a part of the country that almost never sees tropical winds. Will that happen? The honest forecaster's answer is probably not at the high end, but do not bet your safety on it, and there is a recent memory that explains exactly why that caution exists. Not long ago, Hurricane Helene was modelled with a swath of 80 to 90 mile per hour wind gusts pushing inland through Georgia and the Carolinas and into the southern Appalachians, and a lot of people, including some forecasters, looked at that and thought there was no way a storm could carry that kind of wind that far from the coast. It happened, and it was worse than what had been modelled. The mountains of western North Carolina suffered a catastrophe that few saw coming, in part because the inland wind and water threat from a weakening tropical system was underestimated. So when the models hint, even faintly, at this week's system carrying damaging gusts hundreds of miles inland, the people who lived through Helene are not laughing it off. They have learned what an inland tropical system can do when the atmosphere conspires to keep it alive, which is the exact loophole we have been describing this whole time. There is a phrase forecasters use for situations like this, when two distinct storm systems begin to interact and feed off one another. They call it a multi-driver convergence, and it is exactly what it sounds like. Two separate engines of severe weather drawing close enough that their influences overlap and compound. The northern trough and the southern tropical system are, by Thursday, near enough on the map that the moisture from one becomes fuel for the storms of the other, and the wind fields begin to interlock. When that happens, the whole becomes more dangerous than the sum of its parts, because the ingredients no longer have to come from one source. They arrive from two directions at once, layering instability on top of moisture, on top of spin, across an enormous footprint of the country. Step back and look at the map of Thursday for a moment, because it is genuinely something to behold. Up north, the remnants of the Midwest outbreak and the trough's eastward push. Down south, a tropical system spinning out tornadoes and dropping a foot of rain along the Gulf, and in between, a sprawling zone of severe thunderstorms connecting the two. By Thursday, these are not two separate weather systems anymore. The northern machine and the southern machine begin to merge into a single, continent-scale, severe weather event, and the number of people caught underneath it is staggering. So let me show you Thursday, the day this whole anomalous pattern reaches its widest, when more than 120 million Americans wake up under some level of severe weather risk at the same time. Part 10. Thursday, a nation under the gun. There are days when severe weather is a local story, a county or two, a single line on the evening news. Thursday is not going to be one of those days. Thursday is going to be a day when more than 120 million people, better than a third of everyone in the United States, are under some level of severe weather risk at the same moment. Take a second with that figure. 120 million. That is not a region. That is a sizable fraction of an entire nation under one sprawling connected threat, and it is the direct result of the anomalous pattern we have been tracing from the very first minute of this video finally reaching its maximum width. Here is how Thursday lays out. The Storm Prediction Center has a broad Level 2 risk, what they call a slight risk, stretching all the way from Nashville, Tennessee up the spine of the country to New York City, and a marginal risk that reaches west toward Lubbock, Texas and south, down to the Gulf Coast. When a single day's severe weather outlook has to be drawn to include both New York City and the Gulf of Mexico, you are not looking at a normal forecast. You're looking at a pattern that has spread itself across most of the eastern half of the country. The primary threat across that enormous zone is damaging straight-line winds, as numerous clusters of thunderstorms develop through the afternoon and evening and barrel along, knocking down trees and power lines over a huge area. It is worth understanding why the threat changes character on Thursday, from the focused, violent tornado threat of Wednesday to the sprawling, wind-driven threat of the day after. On Wednesday, all the ingredients are concentrated, the shear and the instability and the lift all stacked in the same place over the Midwest, which is what allows for those discrete rotating supercells. By Thursday, as the system pushes east and the cold front sweeps forward, the storms tend to organize into longer lines, and lines are wind machines more than tornado machines. The danger does not go away. It just spreads out and changes its weapon, trading the rifle of a single violent tornado for the shotgun of widespread damaging wind across a dozen states. And remember, all of this is happening on top of the southern story. While the Northeast and the Ohio Valley deal with their wind threat on Thursday, the Deep South is simultaneously dealing with the tropical system, the flooding, and that second tornado front we just described. There are in effect two overlapping severe weather events sharing the same calendar day, one born from the northern trough and one born from the southern tropical system, and the people living in the seam between them, across the Mid-South, could be watching threats approach from two directions at once. That is the kind of setup that stretches emergency management, that fills every meteorologist's screen, that turns a single broadcast into an all-hands event. It is hard to overstate what a setup like this does to the people whose job it is to keep the rest of us safe. Emergency managers, storm spotters, power crews, and the forecasters themselves are looking at a stretch where there is no single moment to brace for and then exhale, but rather day after day of life-threatening weather across overlapping parts of the country. The same weather offices issuing tornado warnings for the Midwest on Wednesday are coordinating flood warnings for the Deep South on Thursday and already watching the next system spin up for the weekend. Resources get stretched thin, fatigue sets in, and for ordinary families the danger is not one decision but a series of them, made over many days, often in the dark, often while tired. That is the hidden cost of a locked-in pattern, and it is one more reason to take the early days of this stretch seriously, because the attention you spend preparing now is attention you will be grateful you did not have to summon at 2 a.m. later in the week. If you have outdoor plans on Thursday anywhere from Texas to New York, this is the part of the video where I ask you to take a hard look at them. Have a way to get warnings. Know that the threat is real even far from the Midwest tornado box, because damaging winds from a fast-moving line of storms can do nearly as much harm as a weak tornado, and they cover a far larger area. The whole reason we're walking through this 2 and 3 days ahead of time is so that the warning does not arrive as a surprise. You now know what Thursday holds. You can plan around it. That knowledge is the entire value of watching the sky the way we do. But here is the thing that elevates this from a bad week to a genuinely remarkable one. It still does not end on Thursday. The pattern that has produced a record-flirting low, a violent tornado outbreak, a rule-breaking tropical storm, and a 120 million person severe threat is not finished, because the same anomaly that made all of this possible is showing no sign of breaking down as the week ends. There is more coming over the weekend, another round building in the plains and aiming at the Midwest all over again, and the persistence of this pattern is, in some ways, the most telling clue of all about what is actually going on in the atmosphere this June. So let me show you the weekend, and then let me pull the camera all the way back, because there is a bigger picture here that I think is the real story underneath the storms. Part 11. The weekend the pattern won't quit. You would think that after a record-flirting low, a violent tornado outbreak, a rule-breaking tropical storm, and a severe threat covering a third of the country, the atmosphere would be spent. It is not. The most revealing thing about this entire stretch is not any single day's violence. It is the refusal of the pattern to break down, and the weekend is the proof. because as the Midwest outbreak winds down and the Gulf system pinwheels off toward the Atlantic, another round is already loading in the plains, aimed at doing the whole thing over again. The forecast for Saturday brings a renewed risk of severe weather to the central plains, with damaging winds and large hail looking like the most likely hazards as a new storm system tries to organise. Then on Sunday, that threat is expected to shift east into the Midwest and Ohio Valley once more, and there are early signals that Sunday could become the more significant of the 2 days, with all hazards possible. If that sounds familiar, it should. It is the same script as this week, a plain setup on one day, sliding into a Midwest and Ohio Valley setup the next. The same geography taking repeated hits from the same kind of pattern. Now, I want to be straight with you about the uncertainty this far out, because the weekend is genuinely murky, and anyone who tells you otherwise is selling certainty they do not have. The models disagree. The European model initially wanted to send the weekend storm system well off to the north and east toward the Midwest, and then on a later run it backed off, showing a weaker low on Saturday with just some thunderstorms scattered across Nebraska, Kansas, Iowa, and Missouri. The timing of the low on Sunday is going to be the crucial detail, as it tracks across the central plains and into the Midwest, and right now the spread between the model solutions is wide, so I am not going to stand here and promise you a Sunday outbreak. What I will tell you is that the ingredients for at least some significant severe weather are likely to be on the table again, and that this is a forecast worth checking back on as the weekend gets closer. But the specific details of the weekend matter less, for our purposes, than what the weekend represents. Think about the whole arc. Tuesday, a warm-up. Wednesday, a violent tornado outbreak. Thursday, 120 million people under threat. Friday, a tropical system raking the southeast. Saturday, a new plains threat. Sunday, another Midwest and Ohio Valley threat. That is not a single storm passing through. That is a pattern that has set up shop over the United States and refuses to leave, firing round after round at the same parts of the country, day after day after day. And a pattern that persistent, that locked in the middle of June, is the real headline. The individual storms are symptoms. The pattern is the disease. This is the moment to ask the bigger question, the one that has been sitting underneath this entire video. Why is this happening now? Why is a setup that belongs to April refusing to break down in the back half of June? What is holding this anomalous trough in place and feeding it day after day? Those questions pull us away from the radar and toward the deeper machinery of the planet, and they lead, as so many of these stories do, in two directions at once. One direction is up, toward the sun and space, the place this channel usually looks first, and the other is down, into the ocean. So let me take both, one at a time, starting with the question I know some of you are already typing into the comments. Is the sun behind this? Part 12. The sun had nothing to do with this. If you've been around this channel for a while, you know we spend a lot of our time looking up, at the sun, at solar storms, at the way space weather can ripple down and touch the Earth. So I want to address something head on, because every time a big weather event like this hits, the question comes in, and it is a fair question. Is the sun doing this? Is there a solar storm, a coronal mass ejection, some burst of energy from 93 million miles away that is winding up the atmosphere and spawning these tornadoes? And the honest, data-grounded answer this time is simple. No. And I think it is important to say so clearly because knowing what is not causing something is just as much a part of real science as knowing what is. Let me show you the space weather picture as it actually stands right now. The sun, this week, is quiet. The geomagnetic field around the Earth is calm. The planetary K-index, the number we use to measure geomagnetic storming on a scale up to 9, is only expected to peak somewhere around 4, which is below the threshold for even a minor geomagnetic storm. There are no significant solar flares lighting up the charts, no major Earth-directed coronal mass ejections barreling toward us, nothing in the space environment that would register as a driver of terrestrial weather. By the standards of what this channel usually covers, the sun is having one of its sleepier weeks, and that quiet is exactly what makes this story so clarifying, because it strips away the temptation to reach for a cosmic explanation. This violent week of weather is being generated entirely within our own atmosphere, by the jet stream and the warm Gulf and the ordinary, terrifying physics of air. The sky did this on its own. I want to spend a moment on the other explanations that always surface during an event like this, because we believe in meeting them honestly rather than mocking them. Whenever a large, well-forecast outbreak appears days in advance, some people will say it is too perfect, too predictable, that it must be engineered, that someone is seeding the clouds or steering the storms or using some hidden technology to manufacture the violence. I understand the instinct. When the world feels chaotic, the idea that someone is in control, even a sinister someone, can feel less frightening than the truth, which is that no one is steering this at all. But let me tell you where the science actually stands, because the physics here is decisive. The energy contained in a single one of tomorrow's supercells is comparable to that of many nuclear weapons. The pattern driving the whole event spans an entire continent and reaches from the surface of the Earth to the edge of the stratosphere. There is no technology on this planet, none, that can create or steer energy on that scale. Cloud seeding, the one real weather modification technique we actually possess, can coax a few % more rain out of a cloud that is already raining. It cannot conjure a trough, it cannot bend the jet stream, and it certainly cannot build a tornado. The reason forecasters can see this setup coming days ahead is not that someone planned it. It is that the laws of physics are predictable, and a big enough pattern leaves fingerprints long before it arrives. So we can rule the sun out, and we can rule out the idea that human hands manufactured this. What we are left with is the atmosphere itself, behaving in a way that is rare but entirely natural. And that brings us to the one factor that genuinely is loading the dice this week, the factor that is not in the sky at all but in the water. Because while the sun has nothing to do with this, the ocean has everything to do with it, and the state of the ocean right now is the thread that connects this June week of violence to a much larger story we have been following on this channel for months. So let me take you down to the warm water that is quietly feeding all of it. Part 13. The warm water underneath it all. If the sun is not the engine behind this week, the ocean is the fuel tank, and right now that fuel tank is dangerously full. The Gulf of Mexico is running warm, and not by a little. Those record-high moisture values over Texas, the precipitable water near the top of anything ever measured there for mid-June, do not come from nowhere. They come from a warm sea surface evaporating water into the air at a furious rate, loading the lower atmosphere with the moisture and the latent heat that storms feed on. A warm Gulf is a more energetic Gulf, and a more energetic Gulf means that when a trough does reach down and light the fuel, the fire burns hotter. The same warm water is what makes the tropical system possible in the first place, and it is what soaks the deep south soil enough to maybe, just maybe, let that storm cheat death over land. The ocean is underneath every single part of this story. This connects directly to something we covered just yesterday in our video on the early arrival of El Niño. For those who missed it, the short version is that the climate pattern known as El Niño, a periodic warming of the central Pacific Ocean, arrived this year weeks ahead of schedule and is strengthening faster than the models built to predict it expected. El Niño does not just live in the Pacific. It reorganizes weather patterns across the entire planet, including the position of the jet stream over North America and the temperature of the waters feeding the American coastline. We talked yesterday about how the same warm ocean signal was already cashing a check on American soil, with that life-threatening flood setup beginning to unfold over Texas. Well, here we are, one day later, watching that exact check clear, the flood arriving, the tropical system organizing, the moisture surging north into a tornado outbreak. The ocean story and the storm story are the same story, separated by only a day. I want to be careful and honest here, because this is the kind of topic where it is easy to overreach in either direction. We covered, in an earlier video on this year's unusual tornado season, the genuine peer-reviewed science showing that the environments which breed severe storms, the combination of instability and wind shear, can be influenced by the swing between El Niño and La Niña, and that a warming world tends to load the lower atmosphere with more of the instability that fuels these storms. That is real research, and we are not going to pretend it does not exist. But I am also not going to stand here and tell you that climate change reached down and made this specific tornado outbreak happen, because that is not how the science works, and anyone who claims certainty in either direction is going past the evidence. Single events are not the same as long-term trends. What we can say, honestly, is this. Out-of-season outbreaks have always happened. This is a rare but natural configuration, and it is unfolding over an ocean that is unusually warm, which tilts the odds marginally, but really toward the more energetic end of what is possible. That is the honest middle ground, and it is where the data actually sits. It is worth saying plainly how unusual it is to be discussing an early-season tropical system and a record-warm Gulf in the same breath as a June tornado outbreak, because that combination is the real fingerprint of this particular summer. In an ordinary year, these would be separate conversations, separated by weeks or months. The tornado season would be winding down as the tropical season slowly spun up. Instead, this year they are happening on top of each other in the same week, fed by the same overheated ocean, and that overlap is the kind of thing that makes the people who study these systems for a living sit up a little straighter. It is not proof of anything by itself, but it is a data point, and it is the kind of data point worth remembering as the rest of the summer unfolds. There is, believe it or not, a sliver of good news buried in all of this, and it is worth holding on to because not every consequence of this pattern is a disaster. The same tropical system that threatens the Deep South with catastrophic flooding is forecast to deliver something the Carolinas genuinely need, which is rain to a region that has been running dry. Drought is its own slow-motion emergency, and a soaking rain, delivered gently enough, can be a gift rather than a threat. Whether the Carolinas get the gentle version or the destructive version depends on exactly how strong that system is when it arrives, which loops us right back to the great unanswered question of whether it strengthens over land. The same uncertainty that makes this storm dangerous also makes it, in one corner of the map, potentially beneficial. The atmosphere rarely deals in pure villains, so we have followed the fuel all the way down, from the tornadoes in the Midwest to the warm Gulf water that feeds them, to the early El Niño quietly reshaping the season, to a drought-stricken Carolina coastline that might, depending on a coin flip in the sky, get relief instead of ruin. We have ruled out the sun. We have ruled out the conspiracies. We have traced one anomalous June pattern as it expresses itself in wind and water across half a continent. There is only one thing left to do, and it is the hardest thing, because it means sitting with the questions this week leaves unanswered. So let me bring us home to the mysteries that even now, with all our satellites and models and supercomputers, we cannot fully solve. Part 14. The question that won't be answered until it happens. There is a strange and humbling truth at the centre of modern weather forecasting, and tomorrow is going to put it on full display. We can now predict the environment days in advance with an accuracy that would have seemed like sorcery a generation ago. We can tell you, 2 days out, that the instability will reach 3,000 joules per kilogram, that the shear will support rotating storms, that the significant tornado parameter will climb past 7 across a multi-state warm sector. We can draw the box, we can name the cities, and yet there is one question we still cannot answer until we are standing inside the event, watching it unfold in real time, and it happens to be the single most important question of all. Will the storm stay discreet? I keep coming back to this because it really is the whole ballgame, and I want you to understand why it is so hard. The ingredients for tomorrow are like a pile of dry wood, gasoline, and a box of matches. We can tell you, with great confidence, that there is enough here to start a terrible fire. What we cannot tell you is the exact shape the flames will take, because that depends on tiny, almost unmeasurable details that only reveal themselves in the moment. It depends on where this morning's cluster of storms ends up, and how much it works over the atmosphere, and how fast the air recovers behind it. It depends on the precise moment the first storm breaks through the cap, and whether its neighbours give it room to breathe or crowd in and choke it into a line. These are mesoscale details, small-scale and chaotic, and they live at the very edge of what even the most powerful supercomputers on Earth can resolve. So here is what to actually watch for tomorrow if you want to read the day the way a forecaster does. Watch the late morning and early afternoon. Watch whether that first round of storms clears out and lets the sun break through, because sunshine reloads the instability and primes the warm sector for the main event. Watch whether the storms that fire around 4 and 5 o'clock stand alone, with clear sky between them, or whether they immediately begin to merge. If you see isolated, towering storms going up by themselves across Illinois and Indiana in the late afternoon, each one alone on the radar, that is the dangerous signature, the discrete supercell mode that produces the strong long-track tornadoes. If instead you see a solid line forming fast that shifts the threat toward widespread wind, either way is dangerous. But the difference between them is the difference between a damaging day and a historic one, and we will not know which we got until it is happening. I think there is something genuinely important in sitting with that uncertainty rather than papering over it. We live in a moment that demands certainty, that wants the forecast to be a promise, that treats every missed prediction as a failure or a conspiracy. But the atmosphere is not a machine that runs on rails. It is a fluid, chaotic system, and the honest forecaster's job is not to eliminate the uncertainty, but to tell you exactly where it lives so you can prepare for the full range of what is possible. Tomorrow the uncertainty lives in storm mode. The professionals have done their part. They have seen this coming for days. They have drawn the box. They have told you the worst cases on the table. What happens next is up to the sky, and the only rational response for anyone living under that box is to prepare for the worst version and hope for the gentler one. And that uncertainty, that gap between what we can know and what we cannot, is not unique to the tornadoes. It runs through the southern half of this story too, through that rule-breaking tropical storm, and it connects to an even deeper question that this entire week forces us to ask. Because if a storm really can strengthen over land, and if a trough really can lock itself this deep into the middle of June, then maybe some of the rules we thought we understood about the atmosphere are softer and stranger than we like to admit. So let me take us into the last and largest mystery of all. Part 15. The Rule Breaker and the Locked Sky. Let us return, one last time, to the strangest thing about this week. The storm that may strengthen over land because it is a doorway into something bigger. For most of the history of meteorology, the rule was treated as nearly absolute. Tropical systems need the ocean. Push them onto land and they die. And yet over the last couple of decades, scientists have documented case after case where that rule bent, where a storm moved inland and refused to weaken, or even gained strength, fed by warm, saturated ground behaving like a shallow sea. The brown ocean effect is not science fiction. It is a recognized, studied phenomenon. But here is the humbling part. We are still learning exactly when and why it happens, still mapping the precise conditions that let a storm cheat its own death. It sits right at the frontier of what we understand, in that territory where the textbooks are still being rewritten. That is what makes this week such a remarkable thing to witness in real time. We may be about to watch one of those rule-bending events unfold, with modern instruments trained on every part of it, and whether the storm strengthens over Alabama and Georgia or quietly falls apart will teach us something either way. If it holds together and intensifies inland, it becomes another data point in a growing pile of evidence that the old rule has more exceptions than we thought, especially as the land and the air grow warmer and wetter, and if it fizzles, that tells us something too about the limits of the loophole. This is science happening live in front of all of us, and you get to watch it knowing exactly what question is being tested. But the storm over land is only one of the rules this week is bending. The other is the calendar itself. Step back and ask the question we have been circling. Why is a trough this deep, this anomalous, 3 to 4 standard deviations beyond normal locked into the middle of June, and refusing to break down across an entire week? The honest answer is that we do not fully know. Patterns like this, where the jet stream buckles into a deep persistent shape and then stalls, are tied to large-scale phenomena with names like blocking patterns and atmospheric waves that circle the whole planet. Sometimes the wave train locks into place, and the same trough sits over the same region for days, firing storm after storm the way this one is doing. We can describe it. We can sometimes see it coming a week or so out the way we saw this. But why it locks in when it does, and why this particular June, are questions that push right up against the edge of the science. And that leads to the thought that I think should stay with you longest, the season ahead question. A tropical system organising this early, in the middle of June, over a Gulf-running record warm, paired with an El Niño that arrived weeks ahead of schedule and is strengthening faster than the models predicted, is the kind of thing that makes a forecaster uneasy about the months to come. I want to be clear that this is speculation, flagged as speculation, the forward-looking part where we leave the solid ground of the current forecast. But the pattern recognition is hard to ignore. When the atmosphere starts breaking out its most violent tricks weeks ahead of schedule, when the ocean is preloaded with record heat before the season has even properly begun, it raises a question that no model can fully answer yet. If this is what the middle of June looks like, what does the peak of the season have in store? That is not a prediction. It is a question, and it is the right one to be asking as we walk into the rest of this summer. So we arrive, finally, back where we started, at a red box on a map in the wrong month, and at the single pattern that drew it. We have followed that pattern from the engine in the upper atmosphere to the cities in its path, from the tornadoes of the Midwest to the floods of the Deep South, to the rule-breaking storm crawling toward the Carolinas. We have ruled out the sun. We have ruled out the conspiracies. We have traced the fuel down into a warm and restless ocean. There is only one thing left to say, and it is the thing this entire week has been trying to tell us. Part 16. What the sky is telling us. Here is what I keep coming back to, after laying all of this out. Everything we have talked about for the last 2 hours, the violent tornado outbreak, the record-flirting low, the tropical storm that may strengthen over land, the catastrophic flooding, the 120 million people under threat, the weekend round still to come. All of it is not a series of separate disasters. It is one machine, one anomalous continent-sized pattern, reaching out of the wrong season, pressing down on the country from the plains to the Carolinas, and choosing to speak in tornadoes here and floods there, and a rule-breaking storm somewhere else. The genius and the terror of a setup like this is exactly that unity. When you learn to see it as one thing instead of many, the whole week snaps into focus, and you understand why the forecasters reached for words like outbreak and catastrophic and once in a few years. And that is the real reason the title of this video is what it is. This is something far worse than a typical June storm, not because any single tornado or any single flood is unprecedented on its own, but because the pattern that is producing all of them at once does not belong to June at all. It is a springtime machine running weeks late, with a warm ocean pouring fuel into it, and it has decided to do its work over the heart of the country during a month when most people have stopped watching the sky. That gap between how dangerous this pattern is and how little attention this time of year usually gets is the most dangerous thing of all. It is the reason a warning matters. It is the reason knowing matters. I've spent the better part of 2 hours walking you through maps and numbers and mechanisms, but underneath all of it is something simpler, almost ancient. For all our satellites and supercomputers, for all the skill we have gained in seeing these things days before they arrive, we are still, in the end, small creatures living at the bottom of an ocean of air that does what it will. We have gotten very good at reading its intentions. We have not gotten any better at changing them. And maybe that is the right relationship to have with a force this size, to watch it closely, to respect it deeply, to prepare for it seriously, and to never make the mistake of believing we have it tamed. So if you take one thing from this video, let it be this. The atmosphere does not read the calendar. It does not know that it is supposed to be quiet in June. It follows the physics, and when the physics line up the way they have this week, it will reach back into the wrong season and pull out its worst, whether we are ready or not. The only thing that changes the outcome is us, paying attention, making a plan, having a way to be woken in the night, choosing to turn around at a flooded road. The storm is going to do what the storm is going to do. What we get to decide is whether it finds us ready. Watch the sky over the next few days, watch that red box tomorrow, and notice whether the storms stand alone or merge into a line. Watch the Gulf and see whether a storm really can gain strength over dry land. Watch the rain pile up across the Deep South and the threat march east across a third of the country. And as you watch, remember that you're not just looking at a string of bad weather. You're looking at a single, rare, beautiful and dangerous expression of a planet whose rules are softer and stranger than we like to believe, doing something in the middle of June that it is not supposed to be able to do at all. Stay safe out there, have your plan ready, and keep looking up, because the sky still has plenty left to show us, and the next few days are only the beginning of what this restless, overheated, rule-breaking summer has in store.